Hi guys, so I hope you're liking my sessions and we are going to start with a new chapter today. So from here on out there won't be any theory part and it will be more of interesting and problematic sessions. So let's get right on to it. So the third chapter is named as basic definitions and interrelationships. So I'll be drawing a diagram here which I will explain. Just let me draw it. Okay, so something I have drawn here, this is called as three-phase diagram. Why three-phase? These are called as the phases. What is this diagram representing? This diagram represents a general soil which will have soil particles in it and will have spaces which will be filled either with water or air or both. Now the terms here, you just have to remember them. Now I'll be writing volume on this side and weight on the other side. Okay, so this is air. Air volume is represented by VA, V suffix A. Similarly, V suffix W for water and V suffix S for solid. Now these two elements will be present in the voids of the soil, so we can represent it by VV. The combination of VA and VW is equals to VV. This is nothing but volume of the void, because these will be present inside the voids only, right? The total volume of the void plus the solids will give you total volume V. That is nothing but VV plus VS will give you V. Clear? Now air won't have any weight, so weight of air WA will be equals to 0, but water will have weight and solids will have weight. Now the total weight, if we say, will be equals to WW plus WS, which is represented by just W, total weight, capital W of course. I'll tell you the reason in a second. Now there are few terminologies like dry soil, fully saturated soil, a lot of this stuff. What do you mean by dry soil? Dry soil is the one in which dry, what does the dry meaning? Water won't be present in the soil. Then in that case the soil will be dry soil. So it will have only solids and air. Similarly, fully saturated. See, in geotech, saturated means wet. Fully means completely saturated. There is no air in the soil. In that case, it will have only solids and water. Okay. Now I'll be telling you about a few terminologies which might be new to you, but these are required for further solving the entire subject. So I'll be starting one by one. Just you have to remember the names as well as their relationships. It is very easy. I'll make it as simple as possible. Okay, void ratio is expressed as VV by VS and is given a symbol E, small e. Now, practically speaking, there is no soil which has volume of void equals to 0, like voidless soil. There is nothing like that as such. So in that case, E will always be greater than 0. It cannot be equal to 0. Not possible at all. Got it? Also, E can be greater than 1 too. Can be greater than 1. In that case, the soil will be considered as extremely loose in nature. Secondly, we come to porosity. Porosity is defined by N and is given by volume of voids by total volume of the soil into 100. So it is expressed as percentage. Now, the volume of voids, practically speaking, it cannot be equal to the total volume of the soil. If it is equal, in that case there is no soil. We are talking just about the air. The volume of voids will be equal to the total volume. So in that case, eta value or N value will always lie between 0 and 100% only. It cannot be equal to this. It cannot be equal to this too. Thirdly, we'll speak about degree of saturation. This is defined as S and given by volume of water by volume of voids into 100. Now, volume of water I have explained. Volume of voids is nothing but volume of water plus volume of air. There's nothing much here. Only thing is S has the limit as this. It can be equal to 0, which means completely dry state of the soil, and it can be 100 too, which is fully saturated case. The last one is water content, represented by small w. Now we know there are a lot of methods of calculating water content, but the most general method used, which you might have done in your engineering, is oven drying method. We just have to learn only this method. Don't go searching for the other methods. There are 6 methods total. So just water content according to oven drying method, there is a formula W2 minus W3 by W3 minus 1. I suggest don't mug up the formula at all. Please try to understand. It is very easy. I explained water content. Water content is given by weight of water by weight of dry solids. Okay, this is the formula for water content. Now relating this to this, weight of water shall be W2 minus W3. Okay, now in that case I am defining 3 terms. First, W1 is the weight of the empty container. I'll take a container. W2 will be weight of the soil plus wet soil, weight of the soil plus the container, and third will be, I'll be drying it in an oven for this much temperature. So W3 will be weight of dry soil. This soil is wet. This soil will be weight of dry soil plus the container. Okay, now if you see, W2 minus W3 will give you the weight of the water. Container cancels. Wet soil minus dry soil will give you the weight of the water. Soil's weight won't change. Now W3 minus 1. 3 minus 1 will give you empty container. So container cancels. We will have only dry soil. We get WW by WD. So water content is done. Now we'll be talking about density. See, strictly speaking, what we have learned in physics is called as mass density. Rho. Rho is given by mass by volume. This is nothing but mass density. Okay. But in geotech, we'll use something different. I'm sure you would have seen this. This is called as gamma, and it's defined as weight per unit volume. This is called as unit weight. We'll be using all the time unit weight only from now on. So we were talking about the unit weight. Now I'm going to define some types of unit weight, such as bulk unit weight. First type, bulk unit weight is given by gamma, which is defined as weight by volume. This is a normal one. Secondly, we have saturated unit weight, saturated, which is given as gamma sat. Submerged unit weight, which is given by gamma dash. Gamma dash will be from Archimedes principle, nothing but gamma sat, weight of the soil in water, minus the buoyant force. It follows Archimedes principle, just remember. It has been asked in the past year gate questions. Okay. After that, the last one will be gamma s, which is the unit weight of the soil. Now I'm going to discuss a very important concept called as G, specific gravity. So there are two types of specific gravity. The first will be apparent specific gravity. There are different names. Please try to remember these names. Mass specific gravity, apparent or bulk specific gravity, all are the same. Okay. And there is another one, which is absolute specific gravity. From gate point of view, this is not required for us. Apparent, mass or bulk, what is the specific gravity? This is given by Gm. Gm is unit weight of the soil to the unit weight of the water or standard fluid. This is specific gravity's standard definition. Now there can be variations in this, such as gamma d by gamma w, which means the soil is in dry state, or gamma sat by gamma w in case soil is in saturated state. Got it? Now I'm gonna write one relation. Just remember this. This will help you in various forms. Gamma s is greater than gamma sat, is greater than gamma d, greater than gamma submerged, or gamma dash. Just remember this. It can be asked as a comparative question. Now there are two more terms. Just try to remember this, not that relevant, but still can't skip anything. Air content given by AC. Now the air content AC is given by volume of air by the total volume of the voids, VA by VV, and percentage air voids, this is given by eta A or NA, similar to porosity, VA by V into 100. Okay. So I guess till here it is clear. Now I'm gonna write some basic relationships between the all these parameters, which will be used in the problems. First will be E is equals to W into G by S. Secondly, we have porosity is equals to void ratio by 1 plus void ratio. Thirdly, we have gamma, that is unit weight, is G plus ES into gamma W by 1 plus W. This is void ratio, degree of saturation, unit weight of water, and water content, specific gravity. Now, unless and until mentioned, just take normal G. If it is mentioned mass, bulk, or apparent specific gravity, then only take Gm. Keep this in mind. Now, we can derive the other formulas using this. If we want gamma D, that means the soil is in dry state. Water content will be 0. In that case, degree of saturation becomes 0. Water content won't be 0. The degree of saturation will be 0. So, G into gamma W by 1 plus W. This will be dry form of unit weight. Then we have saturated unit weight, which is given by G. S will become 1 in that case. We are talking fully saturated here. So these are the relationships. Now, just a small concept which is remaining here. This is the last concept in this chapter. There is a borrow pit here, from which we will borrow the soil. We will carry it and we will dump it to form an embankment. Okay. Let us assume the volume of the soil dug up from this borrow pit is V1. The void ratio of this pit is E1 and water content be W1. Similarly, all this. Now, with various derivations, we can come up to 3 important relations. Just mug up the relations. Volume is directly proportional to 1 plus void ratio. Secondly, dry density is inversely proportional to 1 plus E. So, relating these two, we can get volume is inversely proportional to dry density. Derivations are not required, and applications of this I will be teaching when we will do a problem. Also, if the question is asked how much water content is required to raise the water level content percentage from W1 to W2, you can calculate that by simply using this formula. Either you use this or you use V2 gamma D2 W2 minus W1. The answer will come in kgs always in these two cases. How much water content is required to raise the water level from 1 to 2%? 1 and 2 are nothing but the borrow pit and the embankment itself. Thank you guys, and please do subscribe to my channel. I will be solving problems in this chapter 3, basic relationships, on the next video. Please don't forget to watch and keep on following. Thanks guys.